Hello, this is Mrs. Huntley. This is Module 1, and this is part of your review. I'm going to go over some of the problems on the study guide. In case you were absent from class today or you're just running into some problems, I'll demonstrate how to do some of the problems, and that way it should give you a shove in the right direction as far as completing your study guide. Your homework today is completing the study guide. We'll go over it tomorrow, but it really it's much more beneficial to you if you've actually completed it on your own and you're just making corrections when we're going over it together. So number one we did in class today, but again, in case you were absent or you didn't get it for whatever reason, I'm going to go ahead and do it again. So when you have something in expanded form, like number one is, you want to count how many of each different kind of base you have. So I've got 1, 2, 3, 4 x's, so that's going to be x to the 4th power times y to the 1, 2, 3, 4 power, 4th power. So that should help you in figuring out how to do number 4 and any problem that might look like that on the test. Number 2, we are multiplying powers with the same base, and our properties of exponents tell us when we're multiplying with the same base, we keep our base and we add our exponents. So this is going to be 2 plus 3. Don't forget this has a 1. So it's going to be 2 plus 3 plus 1, which is going to be x to the 6th power. Now I'm going to go ahead and circle my final answer so that you know that is my final answer, not my work. All right, the next one. I could rewrite this one using the commutative property of multiplication. I can say 2 times 3 times x to the 2nd times x to the 5th. That might help me see what I'm doing. So I can multiply my 2 and my 3 together. So that's going to be 6. And then the other 2, I keep my base, x to the 2 plus 5 power, which is going to be 6x to the 7th power. Do you have to rewrite it? Do you have to take this step? No. But for a lot of people, that is very helpful to like group the like bases together so that they can see exactly what they're doing, and to group their constants together so they can see that they can actually multiply those together. So I'm going to have you do 4, 5, and 6 on your own, and we will check them in class tomorrow. Let's move on to number 7. Now this is a division, and hopefully you remember when you're dividing exponents with the same base, you're going to keep your base and subtract your exponents. So that's going to be 5 minus 3 power. So this will be 4 to the 2nd power. Number 8 is the same kind of thing. Do not let the negative base throw you. You're going to keep your negative base, keep it in parentheses, and subtract your exponents. Keep your negative base in parentheses, and 6 minus 3 is 3. So that's going to be my answer. The next one, okay, we already have them grouped, so I have my constants here. I'm going to say 8 divided by 2 is 4. And then I'm going to do x to the 7 power minus 2. So that's going to be 4x to the 5th power. And that would be my final answer. You could also rewrite 8 using the prime factorization. I don't expect you to do that, but if you did that, it would be, you would rewrite this 4 as being 2 to the 2nd power x to the 5th power. Those of you that have done that in the past know that that's a correct answer. Those of you that I just confused, disregard what I said. All right, I want you to do 10, 11, and 12 on your own. We'll go over them in class tomorrow. So we're looking at 13, which is a power to power. When we have power to power, we keep our base and we multiply our exponents. So that's going to be y to the 2 times 5 power, or y to the 10th power. When we have multiple terms and a fraction, this is a power to the quotient power. I can't remember exactly what it's called right now, but the 5 that's on the outside of the parentheses, I almost called them the 5, which is the exponent on the outside of the parentheses, has to hit everything inside the parentheses. So the 5 is going to be attached to the 2. That's going to be 2 to the 5th power, to the x to the 5th power, divided by 3 to the 5th power. and that would be my final answer. Similarly, 15, that 3 that's on the outside has got to hit everything that is inside. So it's going to be 5 to the third, x to the third, and y to the third. Again, none of this is new. If you are getting one of them wrong, or you're not understanding one of them, you're going to have to go back to the lesson that they were contained in. So the first row is from lesson 1, 1 and 2a. The second row is from lesson 2b. And the third row is from lesson 3. So just go back and rewatch any lessons on problems that are giving you a hard time. Next, we're going to look at row 19 and 20. We're going to do problem 19 first. 0 power. So this is going to be 5 to the 3, or well, this is actually power to power. So 3 times 0 is 0. So it's 5 to the 0 power, and we know anything raised to the 0 power is going to equal 1. The next one is a power to power again, and that 0 attaches to everything. So it's going to be negative 2.5 to the 0 power times x to the 0 power. We know anything raised to the 0 power is equal to 1, so that's like 1 times 1, which equals 1. 21 kind of follows that same path, but I'm not going to do that one for you. You're going to figure that one out, and we'll check it in class tomorrow. Problem 22. Don't let yourself be confused. We've got a negative base and a negative exponent. So what I need to deal with is that negative exponent. So my base stays the same, but we know any whole number could be over 1. So when I have a negative exponent, it means I take the reciprocal. It means I flip that fraction upside down. So it'll be 1 over negative 2. My base stays negative, but my exponent is positive when it's in the denominator. If it started in the numerator, when it goes down into the denominator, it's going to be positive. If it starts in the denominator, when it goes up to the numerator, like number 26, it would be positive. Let's look at 23. 23 is actually a multi-step problem. You can do it in a number of different ways. You can start with distributing this negative 2 to everything inside the parentheses, your power to power. Or we can take care of it, being that it's a negative, we can turn it into a positive. Now, many of you struggle with your integer rules and multiplying with integers and that type of thing, so I'm going to suggest on this particular problem, we take care of the negative first. So if I want this to be a positive exponent, I need to flip the fraction, and I'm going to have 1 over this entire thing, 2y x to the 4th, all raised to the positive 2 power. Now I can do my power to power and get that taken care of. So it's going to be 1 over 2 to the 2nd power, y to the 2nd power, and x to the 4 times 2, or x to the 8th power. If you're going, wait, what did you just do? That's okay. I took care of my negative exponent first, which is what made it into a fraction. Remember, if we have a negative exponent, it's going to be a small number. And then I did my power to power once it was down in the denominator. Number 24 should be easy peasy lemon squeezy after that. I've got x to the negative 2 power. Again, it becomes 1 over x to the positive 2 power. I would like you to do 25, 26, and 27 on your own. Let's take a look at 28 and 29. Okay, so 28. I've got a multiplication. My bases are the same, so I keep my base and I add my exponents. 3 plus negative 4. 3 plus negative 4 is a negative 1. I can't leave it as a negative exponent, so I know I need to flip that fraction. It's going to be 1 over 3 to the positive 1, or just 1 over 3. And that is my final answer. 29, I'm going to apply my negative exponent. So it's going to be 2 to the negative 3rd power over 5 to the negative 3rd power, but I can't leave them negative. Remember when I talked about the elevator scenario? If my negative exponent is on the first floor already, it's going to go down into the basement. If it's in the basement, it's going to go up to the first floor. So my 5 is going to go up to the first floor, and my exponent becomes positive. My 2 is going to go down to the basement, and my exponent is positive. So they just flip. It's the reciprocal. I'd like you to do 30 and 31 on your own. 32. Again, don't let that negative base throw you. We're just going to attack it one step at a time. Now we have a multiplication across the top that I think we should attack first. So we keep our base and we add our exponents. And that's going to be over negative 2 to the 9th power. When I do that, I have negative 2 in parentheses to the 7th power divided by negative 2 in parentheses to the 9th power. Now I've got a division. So I'm going to keep my base, negative 2, and it's going to be to the 7 minus 9 power. When I do that subtraction, I've got negative 2, and it's going to be to the negative 2 power. I can't leave it negative, so my final step is putting it into fraction form, 1 over negative 2, still in parentheses, but it's going to be to the positive 2 power. Now notice that my base did not change. My base is still negative there. Whoop, just dropped you. I'm sorry. Okay, the next one looks very complicated, but again, if we rewrite it to group our bases together, it won't be quite as complicated as it looks. So I'm going to use the commutative property to pull out, first of all, my constants that do not have any exponents with them. So I've got negative 2 times 3 times negative 3 times negative 2. I just rewrote them, pulling the constants away from the variables. So next I'm going to write my x terms. So I've got x to the 2nd and then x to the negative 4th. And then I've got y to the 4th and y, just plain y with no exponent on it, so I know that's an exponent of 1. I'm going to go ahead and write that so I don't forget about it. So now I can multiply together my constants. Negative 2 times 3 is negative 6. Negative 6 times negative 3 is positive 18. So this is negative 6 times negative 3, so that's going to be a positive 18 times negative 2. 18 times negative 2. 18 times negative 2 is a negative 36. So my constant here is going to be a negative 36. Now I have to deal with all of my exponents. So I've got x to the 2 plus negative 4, which is going to be x to the negative 2. So negative 36, x to the negative 2 power, then y to the 4 plus 1, or y to the 5th power. I'm going to rewrite it over to the right so I have more room. So I've got negative 36, x to the negative 2 power, y to the positive 5th power. So whatever has a negative exponent attached to it has got to be moving. So being that this is all over 1 now, I know that x to the negative 2 is going to go down into the basement. Now my base, or my constant, can stay negative and stay where it's at. That's not a problem. So it'll be 36y to the 5th in the numerator over x to the positive 2 in the denominator. And that's my final answer. Now that is using a lot of exponent properties that we've learned. So this is, definitely one of the more complicated level 3 questions. 35 is modeled just like 33. So if you followed me on problem 33, you should be fine on problem 35. Let's take a look at the story problems that we have. Let's do problem 36 together. Mark writes 3 to the 3rd power all raised to the 4th power times 3 to the 2nd power all raised to the 3rd power, and that equals 3 to the 5th power all raised to the 7th power, and the teacher marked it wrong. Explain Mark's error and explain how to find the correct answer. So if you want a level 4 on this, you have to tell me what Mark did wrong. You need to tell me what the correct answer is and be able to write about it intelligently. So what I like to suggest that you do, instead of trying to figure out what he did, is to do it right. So I'm going to rewrite the problem. 3 to the 3rd power all raised to the fourth power, times 3 to the second power, all raised to the third power, and I need to find out what that is. So I'm going to do power to power first. Okay, so this is going to be 3 to the 3 times 4 power times 3 to the 3 times 2 power, or 2 times 3 power. So that's going to be 3 to the 12th power times 3 to the 6th power. And that I know I'm going to keep my base and then add my exponents together. So 12 plus 6 is going to be 3 to the 18th power. Now I know that's the correct answer. Let's compare that to what Mark found. Mark said it was going to be 3 to the 5th power to the 7th power. I know he's wrong. Let's see if I can figure out what he did. Now 5 is equal to 3 plus 2. So it looks like Mark added together the exponents that were inside the parentheses, and then he added together the exponents that were outside the parentheses and thought he should leave it as a power to power instead of multiplying it out altogether. So how would I put that into words? I would say, I'm going to type it, get some type going here. Okay. It looks like Mark added the exponents across. What he should have done is the power to power first, and then use the proper and then use the power to power and then multiply the exponents by keeping, oops, I can't type and I can't spell, keeping the base and adding the exponents. What he should have done is power to power. I guess I should explain that further. Multiply the exponent on the outside Okay, so let me see what I wrote here, see if it makes sense. It looks like Mark added the exponents across. What he should have done is the power to power, multiply the exponent on the outside of the parentheses by the exponent on the inside of the parentheses first, and then multiply the exponents, multiply the exponential terms. By keeping the base and adding the exponents. I'm sorry, I should have figured out an eloquent answer before starting to record this, but I didn't. You saw my process of coming up with the answer and making sure that it was fully explained. So I apologize that it was less than eloquent, but I've given you everything that you need to earn a 4 on this type of a problem. So you're going to do your power to power first, multiply that, and then you're multiplying those exponential terms, and when you're multiplying exponential terms, you keep the base and add the exponents. So I hope I've explained this thoroughly. Your homework tonight was actually not watching the video. Your homework is to complete the study guide. So the problems that we did not do together, I just did what I expected you to do in class today. The problems that we just did together, I would like you to do the other problems. You should have exactly what you need in order to be successful on it between your module, the additional resources I gave you, and this recording. There should be no problem. So I expect you to come to class tomorrow with the study guide 100% complete. We will correct it. We'll correct it as though it's a quiz, and any that you get wrong, you know that that's what you need to study tomorrow night. So I hope you have a great rest of your evening, and I will talk to you soon.